the
No.
inclined plane? No. Okay. No. We look at frictional force or the force, frictional force. Here we call it frictional force. Where frictional is adjective, so frictional force. But in your textbook, they call it friction force. No, no frictional. Never mind, right? Same. Friction, there are two types of friction. One is the kinetic friction, or the other one is the static friction. The friction when an object is moving, the friction when an object is not moving. They are they are different. The values, they are different, right? You please read this one, from your textbook. The force
A
of
force of connect a force of kinetic friction. The friction is also the cause when an object is in contact with the surface. Microscopically, tiny protrusions on the interacting surface interlocks and soften and break or bend when force is applied. Kinetic friction is friction that arises during motion. It depends on the materials the surface are made of, as well as how smooth they are and how firmly they are in contact. The normal force is the measure of the firmness of contact. The magnitude of kinetic friction force Fk acting on the object moving on the surface is given by Fk equal UKN,
yeah, it's mu
where N is a mu Kn,
mu k.
where N is the normal force acting on the object. Mu K is called the coefficient of kinetic friction between the object and the surface. Fk is the force acts in the direction opposite that of the motion.
Okay, so we are going to look at the kinetic friction first. Kinetic friction is the frictional force when an object is moving. Let's say if I pull something along the floor. So if the object is moving, then the frictional force which oppose the motion of my pulling of the object is kinetic friction because the object is moving. Now, if I'm pulling this table and the table is not moving, so it doesn't mean that there's no frictional force. There is frictional force, but the frictional force is static friction. Okay, it is the static friction. Okay, regarding the size of this frictional force, in the first case, we know what is frictional force. Frictional force is the force on between two surfaces, and this frictional force oppose the motion. When we want to move to the right, the frictional force is acting on the towards the left side to prevent us from moving. Actually, it also prevents us from slipping. If there's no frictional force, you want to move forward, you will slip, you will fall down, right? So this frictional force actually is useful. Although it opposes our motion, it slows down our motion, but it is useful because it will not make us slip. If there's no friction, you try to move in front, you will slip. Your leg, there's nothing gripping the between the surface. There's no grip between the surface and your feet or your foot. Then you will slip. You will slip behind. So actually it is useful, right? So
Mhm.
kinetic friction is the friction when the object is moving. Static friction is the friction when the object is not moving, the frictional force. Now we want to know the size of this frictional force, right? By knowing the existence of frictional force alone is not enough. We want to know how much is that frictional force in Newton, right? So they say that the frictional force is mu k n, right? Fk. Fk is the frictional force, the kinetic frictional force, the frictional force when the object is moving. So that is Fk. Mu k is the coefficient of friction. Now this coefficient of friction It depends on the surface. Sometimes when the surface is very big, then this coefficient of friction is very big. When the surface, when the two surfaces they are smooth, then the coefficient of friction is small. So this mu depends on the type of surface, on the type of surface. Now another factor that affects the friction is the normal force. The bigger the normal force, the object will have a bigger grip on the surface. If the normal reaction is small, then the grip on the surface is smaller. If
Okay.
the normal reaction is big, then you will have a bigger grip on the surface. So there are two factors that affect the frictional force. One is the type of surface, which is controlled by mu, the coefficient of friction. Another one is controlled by n, which is the normal reaction of the object. Okay, right. So we have F equals to mu k, mu n, sorry. Why they put the small k there? The small k is to say when the object is moving. When the object is moving, the frictional force and the coefficient of friction, they are different from the frictional force and coefficient of friction when the object is not moving. When the object is not moving, they use the symbol small s, static, static friction and static coefficient of friction. But, but in this case, for the start, we are looking at the kinetic friction and the kinetic coefficient of friction. Now, in this table, they give us the value of the mu, okay, the value of the mu, the coefficient of friction. Now, I read the first one, steel on steel. That means the two surfaces, they are steel. The object is made of steel and the surface that is supporting it is also made of steel. So when these two surfaces they are put together, the object and the surface make of both of them make of steel, the coefficient of static friction is 0.74. The coefficient of kinetic friction is 0.75. Okay, the coefficient of friction cannot be more than 1, I see. The biggest is 1 only, right? Cannot be more than 1. Okay, now I ask you, which two surfaces produce the biggest friction? Which two surfaces? Now you look at the down the list here. Can you tell me which one has the biggest frictional force? Or which one will produce the biggest frictional force? Which two surfaces?
Uh, it will be glass on glass.
Glass on glass is 0.94.
Nice.
Is there any number bigger than 0.94?
Rubber on concrete.
Rubber on concrete. So we know that rubber on concrete has the biggest frictional force. Okay, rubber on concrete. So that is why our chairs there's a piece of rubber at the leg there, at the end of the leg of the chair, the leg of the table, there's a piece of rubber there. Because it will give the chair or the table a bigger grip because it has a bigger coefficient of friction. Now this is the list here we are talking about static friction. How about kinetic friction? Can you tell me the list on the right hand side here? Which one has the most or produce the biggest frictional force?
Most frictional force will be rubber or concrete
Yes, it
still.
is rubber on concrete. So this is kinetic frictional force. So if it is very big, then we are in trouble because the two surfaces will wear off very quickly. So for kinetic friction, we wouldn't want the thing to be very big. Static friction, we want them to be big because we don't want them to slip. We don't want them to move easily. We want them to rest in a stable condition. So we don't want them to move about easily. So we want a big frictional force. Now, if it is kinetic, if the object is moving, we don't want a lot of friction. So rubber on concrete will wear out the rubber quickly. Now, can you tell me on this list on the right hand side here, which one has the least friction? Which one has the least friction?
Which one has the least friction? It will be synovial joints in human.
Yeah, it's synovial joint on or in human. So
In humans.
in human, so our joints but the between the two bones the friction is the least in this world in this world because 0.003. So it is very difficult for our joints to wear out, right? So we want the least frictional force, right? So it is the joints, the between the human joints. Okay, so this is desirable, right? This is desirable. The undesirable one will be this one, rubber on concrete. We don't want to move rubber on concrete because it will wear out the rubber. Well, we want this type, the joints, won't wear out our joints. Okay, so we are going to look at